Hello, and welcome to part 2 of my classic snake game tutorial using Python. The program so far is a framework that prepares the game interface. The terminal displays the outline of the game area and waits for the user to terminate the program using Ctrl-C. If that happens, you see a standard Python traceback message. If the terminal does not meet minimal dimension requirements, the program ends with a custom error message. This part will show you how to set up the basic mechanics of the game, including the snake movement and interaction with the player using the keyboard. The full code is linked for download in the video's description. This is a beginner tutorial, but it packs a lot of information, so feel free to slow down the video and watch it at a pace that works for you. Let me explain first how the terminal screen is organized under the cursors library. Each location within the terminal itself and each subwindow within it is referred to by a pair of y-x coordinates. The coordinate system starts in the upper left corner with the coordinate 0, 0. Text is displayed by placing it at a specific coordinate pair. Python has a complex data structure called a tuple, capable of holding multiple values such as a pair of screen coordinates. Normally, tuple members are accessed using numerical indexes such as 0 or 1, but there's also name tuple, which allows referring to the values by a name such as y or x, which I actually prefer as it results in code that is easier to follow. Let me define a new name tuple called point, which will hold a single screen location coordinate pair as y-x values. The body of the snake will be a globally accessible list of such points. Think of them as snake segments. A list is an ordered structure, and it allows changes by adding and removing its elements after the list is created. The snake will initially consist of only one segment, placed roughly in the middle of the screen. The double slash operator represents integer division in Python, yielding whole numbers. It's important to realize that the snake object is held in the computer memory, but displaying it on the screen requires additional steps. The add_str function is the basic method to place content on the screen when using the cursors library. Each content piece is placed starting at a specific y-x coordinate. I will use a full block character to build the body of the snake, represented by a Unicode value of 2588, which looks just like a standard cursor. The index 0 of the snake list refers to the head of the snake. For now, the entire snake is just a head. The refresh method is needed to actually display the snake on the screen after it has been placed using add_str. Let's have a look at what the baby snake looks like. Animating the snake is accomplished by a continuous process of displaying and erasing parts of the snake on the screen. I choose to use a thread for the snake movement, which allows for flexibility in the implementation, including decoupling the snake movement from the keyboard control. The snake movement code will be essentially a large loop controlled through a sleep delay. I will use a globally accessible thread called game. This thread will run code contained in a function called play, which will be the main program loop animating the snake. If you are used to using infinite while true loops, resist that habit when using threading. While threaded code is often a long-running loop, it should not be an infinite loop. Generally, a program needs a way to terminate all threads used, and using a variable to control a while loop is a simple way to accomplish that. All threads have a predefined start method, which simply runs the target function, but there is no predefined stop equivalent, as each program uses threading differently and it is up to the programmer to define the thread termination process. I will add a globally accessible variable called gameOn, which will allow me to terminate the thread later by setting this variable to false. I could place most of the remaining code inside the play function, but it would be rather big, making it hard to understand and maintain. Instead, I will split it into a number of logical sections responsible for functionality such as moving the snake and maintaining the score display. For example, the snake movement code will go into a function called moveSnake. As I already mentioned, well-written programs that use threading must correctly terminate any threads used before the program itself terminates. I need to amend the finally block at the end of the program to shut down this thread before the program terminates. First, I need to check the thread status. The gameOn variable will be true if the thread is active, and if that's the case, I change the gameOn variable to false and wait for the thread to finish its current loop iteration by using the game.join statement. The program will safely exit after that. I expect that the moveSnake function will produce runtime errors, especially while I will be developing the game. I want to gracefully handle game crashes, so I will add a try container here, handling all exceptions in a generic fashion. If the program crashes within the thread, it will display the error description and the thread will end its job. The main program thread will be at the pause statement afterwards, where I can stop the program by pressing Ctrl+C. Let's proceed to the moveSnake function. The job of this function is to animate the snake based on an internal sleep delay. I will set the delay for now to 1 second so I can see well what is happening on the screen when the game runs for the first time. I will change that later. Let's move the snake for now by one screen position to the right. Moving the snake is a 3-step process. First, I need to display a new segment just ahead of the current snake's head position. Once this is done, I need to erase the snake's tail. After these changes are made, they are shown to the user by calling the refresh function. The snake is just one segment long right now, and the head and tail are the same, but this will change later on. Regardless of the snake's length, index 0 will be always the head, while index of -1 will be always the tail. Let's have a look at this in action. The snake should move to the right after 1 second delay. Let me show this again in case you missed it. Yes, that's all that the snake does now. You were probably expecting for the snake to keep moving, but this code will not do that. This was just a test and a demonstration of the animation concept. The animation is a continuous process of adding a new segment to the snake front and erasing the tail. We have only done it once. The snake direction will be controlled using keyboard arrows, allowing it to move in one of 4 directions. I will use named constants available in the cursors library that refer to each of the arrow keys and bind them to y-x direction pairs. Each pair will specify the y or x position increment or decrement applied to the snake as it moves. I use a Python dictionary to store this information, which allows looking up the pairs based on unique key such as key up. As an example, whenever the up key is pressed, the snake will move up by 1 position. The -1 means a decrement to the y screen coordinate, while the 0 means that the x coordinate will not change. The y and x coordinates never change at the same time, otherwise the snake would move diagonally. Let's add the keyboard input routine. Typical Snake game implementations process the keyboard in the same loop which is used for the Snake animation. This is not the best approach, as keyboard should be processed independently from the animation loop to allow user input at least twice for each Snake movement. Otherwise, the game will appear choppy and will not be a good experience. I could add the keyboard read as a separate thread, but it's not necessary, as it can be placed in the main program thread right after the game start. Processing keyboard input with curses is done one key press at a time using a loop. As before, you want to avoid an infinite loop and use a variable-based loop instead, allowing you to stop the keyboard processing if desired. Normally, the getCharacter function call is blocking, which means that the program would wait here until a key is pressed. Because I specified the timeout before, this getCharacter call is not blocking, and the program will only wait for a short time, specified in milliseconds with the timeout. Checking the keyboard 1000 times a second, as it is configured right now, would be a wasteful drain on the system's resources. I am planning to animate the Snake 10 times a second, so reading the keyboard with a 50 millisecond delay is a good compromise, allowing the keyboard to be read twice for each Snake movement period. Checking whether the key pressed is an arrow key is very simple, thanks to the fact that the key codes are stored in a dictionary. This allows me to avoid clunky and inefficient multiple if-else-if structures. They are hard to maintain, especially if you were to add a second player. I will store the key code in a global variable called bearing. This variable will keep the code of the last arrow key pressed, allowing the Snake to continue moving without me having to hold down the keys. Since the Snake is moving as soon as the game starts, it needs an initial bearing. A random choice from the list of directions will take care of that. Now that the Snake has initial direction, and I have the ability to control it, it is time to rewrite the moveSnake function. Let's have the Snake move faster. The new location will be based on the current Snake's head location, adjusted by the bearing. At any given time, the Y position can be changed by plus or minus 1, or the X position can be changed by plus or minus 1. The new Snake segment is added at the beginning of the Snake body. If the game just started, the Snake body is now 2 segments long. The new Snake segment needs to be shown on the screen, and I need to change the old testing code for that. Tail erasing code does not change, but the tail needs to be removed from the Snake segment list. Let's test that. The Snake is moving, but I have a couple of problems. The game crashes, and the keyboard does not work at all. The traceback gives me a hint what the issue is with the keyboard. I still have the pause statement in the start game function. Since this happens before the keyboard processing routine, my program never gets to the keyboard processing part. Let me deal with the pause statement first. It is actually no longer needed, as the keyboard loop will capture the program, preventing the program from terminating, acting as a pause. As you can see, the keyboard is working. But I still have a crash when the Snake tries to go past the game area border. I will deal with this in a moment, but I want to fix the arrow handling itself first. As it is right now, I still need to press Ctrl+C to end a crashed program, and I don't like it. I want the program to exit automatically on crash. Exit traceback tells me that the program was still inside the keyboard checking loop. I need to fix this so the loop is terminated when the program crashes. This is easily done by changing the keyboard loop control variable to false when handling the exception. Right now, the game crashes when the snake reaches the edge of the game area. This check will determine whether the snake's head reached the upper or lower edge of the game area. An additional condition will check whether the snake reached the left or right edge of the game area respectively. Should either of these conditions occur, the snake animating thread will be terminated by changing the game_on variable to false, which will stop the while loop in the plain function. Let's test it. The game now stops when the snake reaches the edge of the game area. I need to test all 4 directions to make sure that I got the conditions right. You may have noticed that the 2 conditions are a bit different. This stems from the fact that the game area subwindow has 1 line less than the full terminal, with the top line of the terminal reserved for the scoreboard. The game is still running, accepting keyboard input after the snake hits the game area border, but the snake itself is not moving as the thread has been terminated. I use Ctrl+C to exit the game right now, but ultimately I would like the player to see a game over message and have the ability to restart the game without exiting or restarting the program. I will make a new subwindow to display this game over message. This will be a small pop-up located in the middle of the screen. The pop-up will be just 4 lines, with top and bottom lines reserved for border, and the 2 middle lines used to communicate with the player. The minimal game window width right now is 50 characters, so the pop-up needs to be smaller than that. Let's make it 40 characters. The remaining 2 parameters of the new when function are the upper left corner coordinates of the pop-up. To place the pop-up in the middle of the screen, I need to first divide the screen height and width by half, and then subtract from that half of the pop-up height and width respectively. Now I need to define the details of the pop-up. Since that needs to be done every time the game starts, I will place that code in the start game function. The game over pop-up will have 2 lines of text inside. I will guess the horizontal placement and adjust it later if needed. Obviously, the pop-up will not be displayed right now, as the game has just begun. Displaying it will be done in the play function after the game detects a collision with the border. Let's test it. That looks pretty good, but it will look better with a border. Almost there. The text needs to be nudged to the right to be perfectly centered. That looks great. Obviously, when I press the spacebar right now, nothing happens, as the accepted keyboard input is limited just to the arrow keys. Let me add the spacebar key to the allowed input. The key code for the spacebar is 32, but I only accept it if the snake is not currently moving. Only if the game is over and the spacebar is pressed, then the game will start again. Calling the start game will reinitialize the game interface and restart the animation from the middle of the screen. Alright, the snake is moving and the user interaction is complete. The next video will show you how to feed and grow the snake and how to keep score. Not a subscriber yet? Please subscribe and hit the like button while you are at it. By subscribing and liking my videos, you are letting me know that what I do makes a difference to you. Thanks for watching.